Okay, we'll go ahead and get started now. So your we have it looks like week 14 material was moved to the due date of the 20th, and week 15 material is also the due date of the 20th. So in order to stay on schedule, we need to do the sections for week 15 today, and then when we meet on our next meeting, we can do the lab for week 15. But before we get into this, I think you guys had more questions about the homework, right? Yeah. So what do you guys feel like doing in this class meeting? You guys want to do homework still, or do you want to do this? All right, well, so if no one seems to need help on the homework, we can move to the sections. So I guess we'll start doing these, and then whatever we don't accomplish in this meeting, you'll be expected to do it over the weekend so that you'll be prepared for the lab when our next meeting comes around. So we are dealing with recursion right now. So just wondering, has Professor Amir gotten around to teaching recursion yet?
Yeah, we just covered it today.
Okay, perfect. So,
and the last meeting too.
Okay, perfect. So before we start this, nobody needs help with the homework? Okay. We'll just do this then. Unless somebody says in the chat that they need help with the homework, then we can move on. We can switch gears onto that.
I think I do want both because I just want to get a better understanding, but it's up to whatever you guys want to do.
Oh, so we should do the homework then? Okay.
Yeah, but it's up to everyone else.
Oh, that's fine.
I wouldn't mind.
Okay. Can someone post a link to the homework in the chat then? Perfect. Thank you. Okay, so which problem should we look at this time? We did this one already, right? So there's just problem 1 and problem 2 to deal with. It looks like problem 1 doesn't really seem that bad. So it says implement a class rectangle, provide a constructor. We've been writing constructors already with width and height, get perimeter and get area. And then make a void function called resize double factor, which resizes. Okay. That doesn't seem too bad. Slim Toki says in the chat, problem 2. Let's take a good look at that. So problem 2 says implement classes person and street address. Each person has a street address. Provide display functions in each class for displaying their contents. Distribute your code over 5 files, 2 for each header file, 2 for the associated source files, and 1 containing the main function. Construct 2-person objects and display them. And you need to create 2 header files with associated source files. You can run the project through IDE or command line. If you opt to use the command line, you can use passing to, you can use passing the complete set of file names for creating a makefile. So, person and street address, did Professor Amir give you these classes?
No, that was just for question 3.
Oh, so he says implement classes person and street address, but he doesn't specify what needs to be included in those two classes.
Yeah, that's good. I was gonna ask is like, what exactly are the data members of this class?
Yeah, that's what I'm wondering.
Because I mean, there's technically like an infinite amount of data members you could put in this class, but how many does he want?
Yeah. Yeah, this is confusing. Like, he doesn't give enough information. He just says implement classes person and street address. Okay, what should they contain? Like, maybe person should contain first name, last name. I don't know if other things might need to be included. And then as for street address, I suppose the elements of that would probably be, it would probably be address, city name, and then zip, right? But I don't want to.
It's only 3. So the address would contain the address number and the street name.
Yeah, address number, street name, city name, zip, probably those. But I don't want to assume because I don't want us to be wrong. He also says construct 2-person objects and display them. So maybe these classes also need print functions as well. Man, I just wish he was a little more descriptive. Well, here's what I'm going to do. I'm going to send him an email. What does he mean by this? Because he wasn't very specific. Because what kind of elements what kind of members should person have? What kind of members should street address have? And you know what? Until he's more specific, I don't think we can start working on question 2. To be honest. So sorry about that. I'll remember to send the email to him after this meeting because I don't want to waste valuable class time. But if I have to guess, here's what I would think. I would think that person needs first name as a string, last name as a string, age probably as an int. We would write setter and getter functions for each. And then we would also need a print function that displays its contents. Street address would probably contain address number, street name, city name, and zip. We would write setter and getter functions for all 4 of those, as well as a print function to display its contents. Now, one thing you should remember when you're making these classes is that you should make, if you're using code blocks, you should make the classes the way that we showed in the last meeting. Like I think Aaron Massey was the one that was showing it before. You click that window and it
Yeah, you just you just use the code blocks native like class builder, and it sets everything up for you, header file and all.
Yeah, that one. And remember that's in the last video. The one that was posted for this. And then it also said what else? Each person has a street address. Okay, so the person class also needs to have a member of type street address. So you should make the street address class first before making the person class.
Well, then, since we don't really know what it contains in the meantime, did you want to tackle number 1?
Well, I was thinking about doing number 1, but not doing number 1. I read it already. It seems a little too easy. I think you guys can do this yourselves.
Yeah, that's fair, actually.
Hmm.
Do we need any header files?
For what?
Yeah, one.
For one? Yeah, you're gonna need a header file uh, for rectangle and then its source file. So you're gonna need a rectangle.h and then a rectangle.cpp.
Okay.
And it looks like he does specify what members are required. You're gonna need a constructor. You're gonna need width and height. Both of those are probably going to be doubles, right? You're gonna need a get functions to get perimeter and area. You know how to calculate perimeter and area. It's just 2 times the quantity of width plus height. That would get you perimeter, and then area is just width times height. And then this resize double factor. This is very easy to implement as well. But I don't know if you guys want to do number 1 anyways. We can.
I kind of do. I kind of really don't. I'm trying to understand it, and I think it's because I'm doing my history exam too, so it's kind of caught up myself.
Yeah, yeah, I know it's tough, especially around the finals. It's all right. Well, if it's tough for you, uh, just if it helps, remember there's a sequence of things to do. First thing you gotta do when you're making a class, you declare its private variables. So after you say class rectangle, in the private section you'll say double width and double height. Those are the private variables. And then the public members are going to be the setter and getter functions for both. And then these 3 additional ones. Okay. So we could start question 1, and that's how you guys feel.
Yeah, that would be great.
Okay. So I'll call this homework 5, problem 1. Okay. So let's add a main.cpp. Right. So we will include IOStream. Now, I'm going to set this aside for now. Let's create the header file. Remember, if you're doing this in code blocks, you should do it the way that Aaron Massey showed in the last meeting. But I'm going to do it this way. So I will add a new item. I'll call you rectangle.h. So we're gonna need a class called rectangle, right? It's gonna need, we're gonna put 2 sections. One is gonna be called public. This will contain the setter and getter functions. and then a section called play. Now, one thing I should really do, I know that you guys do this. You separate the header files and the source files. So I'm going to do the same thing here, even though that's not what I usually do. So I'm going to say, I believe this is how it's done, right? Define. Do I need to put .h at the end of this or no? Does anybody know?
Mine,
It's underscore H.
yeah, underscore 8.
Like this?
Yeah.
Okay, okay.
And then I think there's another underscore of included for all three of it.
Oh, I'm sorry. What?
Sorry, there's an like after another underscore with included with all three of them. That's how ColdBlock sets it up, because like when you do a header file, already writes in the build it up.
Yeah, it also creates the source file. Okay. Right. Unfortunately, Visual Studio doesn't have that feature. I have to make them both separately. But that's okay. I kind of prefer doing that anyways. So this one's going to be called rectangle.cpp. Add. So maybe I'll put this here and I'll put this here so you can see it. Then we can look at the main.cpp later. So the source file always needs to include the header file. So I'll say include rectangle.h. Okay. So over here, I'm going to have all of the function definitions, right? I would put the prototypes here, but the function definitions can go here, right? So here's how we would approach this. So reading this, it looks like rectangle only needs two private variables, right? Width and height, right? So over here in private, you're going to make a double called width and a double called height, right? So after you wrote this, you also need to write setter functions for width and height. So setter functions, the more correct term is called mutator functions. But one thing that you need to know is that they're always of type void, right? So void set width, and this is a function, so I need to put open close parentheses, and then void set height. So far, so good, right? So now, before we move any further, let's define these. So what you should do is copy these, move them here, delete these semicolons, and then put squiggly brackets underneath both, as so, because we need to define what these are. We also need to tell the compiler that these functions are member functions of the class rectangle, and the way you do that is using the scope resolution operator. So you would say the name of the class, in this case it's rectangle, in front of this, and then say colon, like that. Do the same for this as well. So the purpose of the setter functions is that it accepts a data type that's the same data type of the thing that it's setting. In this case, it's a double, and it sets what it's getting equal to that variable. So this actually needs to accept a double. This also needs to accept a double. Let's say double here as well. Double here as well. So when we pass variables, we have to give the variables a name. So maybe we'll call this one W, and we'll call this one H, just because why not? W stands for width, H stands for height. So this function, it accepts a double called W, and we will set width, because that's the private variable that we're trying to set, right? It'll set width equal to W, right? And then same reasoning here. We will set height equal to H, right? So now it says also make this, and this, but I'll write these later. First, I want to show you something. So the fact that we completed this now, that's a good thing. We can actually start using this rectangle class now. I'll move this over here as well. So over here, I'm going to include my rectangle class. So it's called rectangle.h, and I need to put this in quotes, right? Okay, so now that I have this, I can actually start using the rectangle class. So the same way I would define a variable like string name, int, counter, I would say the data type, in this case, is going to be a rectangle. And then I'm going to say the name of this variable. Maybe I'll call this one rectangle 1. Okay. Okay, so now that I have rectangle 1, at this point in time, it has 2 private variables, right? Width and height. I just declared it, and I didn't write a constructor yet. So right now, rectangle 1's width and height, they're not defined. So I'm going to have to use the setter functions in order to set them, right? So maybe I'll say, what should we set the width and height equal to? So maybe I'll set it to 5 and 6, maybe. So if I wanted to set width to 5, I would say rectangle 1. I would access the set width function using the member access operator. That's the period. And then it gives me these options here, right? So I'm going to choose set width. Okay. And this is a function, so it needs open close parentheses. This function requires one argument that needs to be of type double. So maybe I'll put 5.0 in here. And what this does is it sets, it'll go to this function here. 5 is accepted as W, so it'll set the rectangle one's width equal to W. Does that make sense? Okay.
Yeah.
All right, so after that, I also need to set the width. So maybe I'll say rectangle one dot set width, or excuse me, set height. And like I said before, I need to set it to 6. Okay. So after this line of code, when this happens, 6 will be passed as H, and it'll set height equal to H. So now, after these 2 lines of code, width will be 5, height will be 6. Okay. And that's all it does so far. To do stuff that's interesting, we should write the functions that it told us to. So we need a get perimeter function and a get area function that returns the perimeter and the area, right? So in order to include those, what you should do is go over here, and maybe we'll call this one getter functions. So as one thing you need to remember is that functions need to be the same type as the thing that they're returning. These don't return anything, so they're void. But these are returning something, right? Perimeter is of type double. Area is of type double. So we're gonna have to make both of these doubles, right? So we're gonna say double get perimeter. And this is a function that accepts no parameters because we already have the parameters right here. And then we need a double get area. And then the last function it needs is called resize. And it already specifies it's going to be a type void, right? I'll put it here. Okay. So this is all you need. The only thing you got to do left is define what these functions do. So I think I've gone a good enough ways for now. How about on your own, you try to write the definitions for rectangle.h, these functions. So to finish this one, you have to put it here. You have to put the scope resolution operator before. And then inside of squiggly brackets, you say you return you return 2 times the quantity of width times height. To finish this one, you do the same thing, but in the definition you say width times height. Okay. And then for this resize double factor, it doesn't return anything, but you should say that width equals width times factor, and then height equals height times factor. Is that a good enough start for you guys?
So it would all be in H. Are we done with everything else except for defining what the functions are?
Yeah, we did this, but you still need to define these.
That's it.
Yep.
Okay.
And then you also need to write code in your main.cpp that uses it and tests it to see if it's right.
Oh, okay. Like the see out or something
Yeah.
to display.
Okay, so in order to see that, you probably have to write a print function as well. So maybe void print. And inside of the print function, you would say height width equals this, height equals this. So maybe one thing you could do after you define these is you could say, you could say rectangle1.print, and then it shows the width and height for now. Right now it's equal to 5 and 6, but then you call rectangle1.resize and then put a number in the function, so maybe 2. And then when you call rectangle1.print again, it'll say 10 and 12 because you doubled the width and you doubled the height. And that way you can show that the function works. Sound good? Remember, if you need more help, we have next meeting. Right now, I just want to see if you guys can do this for now.
Yeah, I get that.
Like so far, none of this seems hard, right? Like I think you were able to do this on your own. We've been doing this for a good while actually. So to reiterate from before, I'm going to send Professor Amir an email asking specifically what he's looking for with these. And until then, we can't.
A question about the rectangle function.
Mhm.
So do you think it would matter whether we had the program like instantiate the rectangle through a constructor or a mutator function? Like, would either work?
Either one would work. It's good programming practice to do it through a constructor. That way, you know for a fact that every single private member is initialized.
Okay, got it. Thank you.
But oh yeah, this one says provide a constructor as well. We probably should have done that first, huh? Well, it's okay. I'll just make another section here, and you can write the constructor yourselves, or we can talk about it again in a future meeting. Constructors always look like this. It's just the name of the class with the open close parentheses following it. And then to write the definition of a constructor, you put it there, get rid of the semicolon, put squiggly brackets. You need the scope resolution operator as well. This, because this has two, because this has two private members, both of them of type double, this needs to accept double, and this needs to accept double. And don't forget to give these names. Maybe I'll call this A, call this B. You can name them whatever you want. I just decided to name them that. So to finish writing this constructor, you would say width equals A or height and height equals B. Okay, so I think we looked at problem 1 enough. We accomplished a substantial amount. And then don't worry, we can do this. Oh. Now it says this is an error because I didn't write a default constructor. Well, oh, that's okay. We can talk about that in the next meeting. For now, I want to see if you guys can finish writing the definitions for these, and then I'll talk about that. Okay, so here's the main.cpp. Here's rectangle.h. Here's rectangle.cpp. I'm gonna leave it at that for now. Try this on your own, and then we can discuss it more on Tuesday. But for now, we can't make any more progress on question 2 until after I send that email. So if it's all good with you guys, let's go ahead and move on to the sections. Unless anyone else has any more questions on the homework. Or are we good? Okay. I'm just gonna assume everyone's good for now. Okay. So let's move on to the sections. So this is section 15.1, recursion. So one thing that one notable factor about recursion is that recursion is usually in the form of a function that calls itself, right? So if the method to solving a problem or performing an algorithm involves repeating the same step over and over in sequence, one good way you could accomplish your goal is using recursion. So consider this. An algorithm is a sequence of steps for solving a problem. For example, an algorithm for making lemonade is this. Some problems can be solved using a recursive algorithm. A recursive algorithm is an algorithm that breaks the problem into smaller subproblems and applies the same algorithms to solve the smaller subproblems. Okay. So consider this. In order to do this process of mowing the lawn, you need to mow the front yard and then mow the backyard. And then the process for mowing the front yard is exactly the same as the process of mowing the backyard, okay? That's what recursion is. It takes a big problem and breaks it down into smaller problems, okay? So the mowing algorithm consists of applying the mowing algorithm on smaller pieces of the yard, and this is a recursive algorithm. At some point, a recursive algorithm must describe how to actually do something known as the base case. The mowing algorithm could be written as like this. So mow the lawn. If lawn is less than 100 square meters, push the lawnmower left to right in adjacent rows. Else mow one half the lawn and then mow the other half the lawn. So do you notice that this function is calling itself? So the definition of mow the lawn is here. Like this is the function, right? Mow. It calls itself here and it calls itself here. So if you, I think it would be helpful if I drew a little diagram. Okay. I'm gonna do this. Let me grab this and paste it here. So, so you call mow the lawn, right? If lawn is less than 100 square meters, let's say in the first iteration it's not, so that we move to else, right? And you say mow 1/2 of the lawn. So, and then what we would do here is that when this function is called, we would call the definition again, right? So what happened as a result is that when it calls itself, the function essentially makes a copy of itself, right? And it would do these steps and it wouldn't return to the first iteration. So this is the first iteration, right? So this is the first iteration, right? This is the second iteration. We would not go back to the first iteration until we were finished with this, right? But keep in mind, even if we finish this iteration here, this function doesn't terminate until after we do this as well, because we always go do lines of code linearly, right? So after we do this and do all this, then we move here. So when this is called, we would do it again. Right. And that's assuming that in these two iterations, we didn't exit with the base case. And I'm going to highlight the base case here as well. So this is the base case. This is the base case. This is the base case. You may notice that if we're not calling the base case, that's our exit condition, we are calling the function again and we're making more iterations. Okay. So let's answer some of these questions. Which are recursive definitions / algorithms? So the way we know that a function is recursive is if a function calls itself and then breaks a problem down into smaller subversions of that problem. So consider this algorithm helping n people. If n is 1, help that person. Else, if help the first n over 2 people and then help the second n over 2 people. So what do you guys think? Is this a recursive function? Type in the chat if you think it's a recursive function or not. Problem 1. Well, I would argue that this is a recursive definition because if the function here is help people, it says help the first half and then help the second half. So it's calling itself, right? And the base case here would be if n is equal to 1, right? So I would say that this is a recursive definition. What about this one here? Driving the store. This algorithm says go 1 mile, turn left on Main Street, and then go half a mile. Well, what do you guys think? Is this a recursive definition or no? Yeah, it wouldn't be because it's not calling itself, right? So this is false. Next one, sorting envelopes by zip code. If n equals 1, then done. So without looking at the rest of the algorithm, it looks to me like this is a base case, right? And now it says, else find the middle zip code, put all zip codes less than the middle zip code on the left, all the greater ones on the right, and then sort the left, then sort the right. So what do you guys think of this? Recursive or no? I would argue that this is a recursive function because we're saying, hey, to sort these zip codes, take half of them, put them here, half of them, put it here, sort this half first, then sort this, the other half. So I would say this is a recursive function. Okay. Now we can move to section 2. How long is this? Okay. So section 15.2, recursive functions. A function may call other functions, including calling itself. A function that calls itself is called a recursive function. Okay. So take a good look at this function called countdown. So if count equals 0, we would see out the word go, right? Else, we would see out what count in is equal to, and then we would call countdown, but -1, right? So let's take a look at what happens here. Okay. Okay, so this is what I wanted to show you when I wrote this little thing here. When a function calls itself, the way you should try to visualize it is that the first call is here, and then a call makes a copy of itself, and then you wouldn't return into this iteration until the iteration that it calls is complete. So yeah, so this is the first iteration, this is the second iteration. So right now we see outed the number 2 in the first iteration, then we called this. Then we see outed 1 in the second iteration and then called this. It's 1 now because we called itself, but -1, right? And then and because 1 is not equal to 0, we call ourselves again. So this time, countdown does equal 0 because 1 minus 1 is 0. So when this iteration happens, this exit condition finally happens where we say go. So we say 2, then 1, then go. So finally, when this function terminates, we return to where we were before in this function. There was no other lines after this one, so this terminates. And then we go back here, and because there's no lines after this call, this also terminates, which means we finally return to the int main, right? So, makes sense. As you can see, it always scans linearly. So all those functions terminated after we finally reach the base case, right? So each call to countdown effectively creates a new copy of the executing function as shown in the right. Returning deletes that copy. The example is for demonstrating recursion. Countdown is otherwise better implemented with a loop, right? Recursion may be direct, such as f calling itself calling f, or indirect, such as f calling g and then g calling f, right? So let's answer these questions here. This says, refer to the above countdown example for the following. How many times is countdown called if main calls countdown 5? What do you guys think? How many times would the countdown be called if it was 5? Well, I would argue that it's called 6 times because we start from 5, right? So imagine count int was 5, and then we would continue subtracting by 1. We would not exit until count int equals 0. So the numbers 1 through 5, and then including 0, that's 6. So I would say that it's 6. Let's see if I'm right. Yep. How many times is countdown called if main calls countdown 0? What do you guys think? Well, let's consider what happens in the code. If count int was 0, it's being called once then, and then we check this if statement because 0 is equal to 0. We'll say that we'll see out and go, and then this will be ignored, and then we'll terminate, right? So I would say that we only called countdown 1 time, right? Lastly, this question here says, is there a difference in how we define the parameters of recursive versus a non-recursive function? When it says parameters, it's referring to this. I would argue no, there is no difference to how to define the parameters. So I would say no. Yeah. So lastly, we have this challenge activity. Let's try this, and then we can call it a day. So this says, write a statement that calls the recursive function backwards alphabet with a parameter starting letter. Okay. Well, it looks like the function's already made for us. So it looks like we just need to call it now, right? Let's take a good look at what it does. If we say A, if the current letter is A, it'll just output A, right? But if it's any letter other than A, remember, if you take a character and subtract it by 1, you move to the previous character in the list of ASCII characters. So maybe I should pull that up again if you guys want to see it. So imagine the character was S, and then if we subtract 1, the S becomes lowercase r. If we subtract 1 from lowercase r, it would become Q. And then we would continue going down until we reach A, which is our base case, right? So let's just pass starting letter into backwards alphabet and then see how that goes. So we'll say, call the function backwards alphabet, and then we'll put starting letter into it. Run it. Okay, so you see what happens, right? Because we started at Z, we moved backwards until we reach A. Here we start with P, we move backwards until we reach A. Because here we start at A, we just say A. So this function called itself 26 times, right? And this function called itself this many times, and then this time there was only 1, so it reached the base case. Any questions? No? Okay. So we did 2 of these sections already, and we're at time right now. So I expect you guys to do sections 15.3 to 15.7 on your own over the weekend. And then after you do that, we will be ready to do this lab on our next meeting on Tuesday. And then hopefully by then we can start looking into questions too. So aside from that, is there anything else we should discuss before we wrap up this meeting?
I might have to have you maybe take a look question 3 on Tuesday.
Okay, that's fine.
Because it's like really complicated if you think about with all compared to what we programmed so far. Because it has a lot of CPP files and header files.
It has 2 CPP files and 2 header files. So one thing that's nice is that the question class is already made for you. You're just making a new class called fill-in question that inherits from question. Oh, my bad. I just realized I wasn't sharing. Yeah. So question is already written for you. You're just writing a new class called fill-in question that inherits from question. So and then with that, you're just redefining what the public members of question does.
Okay.
And but if you want, we can look at it some more come Tuesday.
Yeah, that would be great.
Okay. So aside from that, is there anything else we should discuss before I wrap this up? Okay. Well, if there's no more questions, I'll just say have a good weekend, and I'll see you guys on Tuesday. Bye-bye.